For centuries, mankind has peered into the heavens at our moon and wondered where it came from, how it came to orbit around the Earth, what it is made of, and why there are so many similarities and differences in the Earth's and the Moon's composition. The Earth's moon is unusually close to the Earth and is a key to life on our planet. It governs the ocean's tide cycles, which may have been necessary to prepare for the first stages of life in our oceans. But its origin has been the subject of a number of different theories. The current leading theory is that a planetoid about the size of Mars smashed into the Earth some 4.5 billion years ago, blasting off a chunk of the early, still developing Earth, and the remains of both planets came together to form the Moon. This has become known as the giant impact theory. Astrogeologists have recently come closer to proving the theory by scientific examination of Earth and lunar rocks brought back by the Apollo missions. Evidence is suggesting that even life on Earth may not have been possible without a cataclysmic event early in the Earth's history. Giant cataclysmic impacts are not new to our solar system. It is generally thought that the planet Uranus, which is tilted on its side, got that way as a result of at least one impact, maybe two, by a planet-sized object in its history. Other planets in our solar system have also shown signs of gigantic impacts. The planet Venus has been the subject of such collisions. Venus, however, doesn't have a moon like ours, so the question arises, why not? If Venus suffered such a similar impact as Earth, why doesn't it have a moon too? There are several scientific explanations for this, which include experiments on how large the rogue planet would have to have been, at what speed it was traveling when it impacted, at what angle did it impact, what effects did gravity have on the remnants of the impact? Perhaps there was a second impact, or maybe a newly forming moon simply spiraled back into the planet. Such occurrences were common during the early formation of our solar system. These questions apply to the Earth too, when trying to determine what kind of impact would have been large enough to produce enough debris to form the Moon without destroying the Earth completely, and also destroying the rogue planet Theia at the same time. The Earth was subjected to dozens of such collisions during its formation. The planets in our solar system were created by collisions between small dwarf planets orbiting the newborn sun. These collisions caused smaller planets to melt together and form larger and larger planets. One theory is that the Earth and the Moon were created at the same time as a result of a collision between two of the larger formed planets. The rogue planet, which is thought to have impacted with the Earth, was named Theia, after the mythical Greek titan Theia, who gave birth to the moon goddess Selene. According to the giant impact theory, there were many more planetoids other than Earth orbiting around our Sun during the solar system's development. Theia, which is believed to have been the size of Mars, is thought to have formed at the same time as the Earth and orbited our Sun too. Theia grew larger, however, making its orbit unstable, and eventually it collided with the Earth. In the last days of planet formation, a body as big as Pluto probably also smashed into Earth after the planet had been clobbered by Theia. Some theorists suggest that this is what could have knocked the Earth off its axis by 10 degrees, where it is today. Theia is thought to have struck the Earth at an oblique angle of about 45 degrees, when the Earth was nearly fully formed. A significant amount of mantle material from both planets would have been ejected into orbit around the Earth. It is estimated that about 20% of Theia's mass would have ended up as debris orbiting the Earth, and about half of this would have coalesced into the Moon. Scientists are trying to determine if this collision was a big splat, where the rogue planet simply merged with the Earth on impact, ejecting enough debris to form the Moon, or whether it was a hit and run where a sizable chunk of the Earth and part of the rogue planet formed the Moon, and the rogue planet continued on its way, still out there somewhere. The Moon at that time was thought to have been very close to the Earth. It would have appeared 15 times as large as it does today, and would have had 4,000 times the pull on the Earth than it does now. It began moving away from the Earth and continues to do so today. Launched in 2008, NASA's Stereo Solar Observatory probes flank the Sun on opposite sides. They are entering an area where they will be able to search for any remnants of Theia which may still be orbiting inside our solar system. Did Theia survive its impact with Earth? If Theia collided directly with Earth instead of barely swiping it, and the collision speed was higher than originally assumed, Theia may have been totally destroyed. If, however, Theia was larger than Mars, hit the Earth with a glancing, slower motion blow, and simply tore off material that formed the Moon, it would have survived this hit and run and went on its way. Is Theia then on its way to interstellar space, never to return? Or was Theia sent into a trajectory that would eventually bring it back into our solar system for another encounter with the Earth?